Good morning. My name is Zoltan Kis. I work for Intel in Finland, and I'm going to talk about provisioning in IoT in general and in particular with Web NFC. Now, NFC stands for Near Field Communications, and I'm pretty sure you all got the hotel card like this that you tap against the lock and then it opens. That's NFC, and it's provisioned at the reception desk with your room and your duration of stay, and it's not going to work after that. About my background shortly, how many of you have seen the smart home demo? Basically, we have implemented most of it with JavaScript APIs. I am working on those APIs on IoTVT, Soletta, and if you have any input on those, they are pretty fresh, still in formation. Any input would be welcome. In addition, I'm working with W3C in standardizing Web NFC. And in the past, I've been involved with system applications that's also giving access to the hardware from web pages. Earlier, on relevant projects, I've been working in network management, with mesh radio networks, also in mobile enterprise and cloud. And something like 20 years ago, I programmed DSPs when I was doing research on AI applied in robotics. And it was amazing that at that time, DSPs were how efficient they were and relatively how fast. And today, basically, what we see is that we can do the same things or similar things with general purpose processors. And in addition, the evolution of the internet and communications now allows us to connect all these formerly local processing units together. So now we have local processing and data sharing and cloud processing. So if we look at the promotional picture of IoT, it looks pretty complex. It has a large number of constrained devices on the left hand. It has communication protocols connecting to servers that have databases, that have load balancing, that have data as a service. It has network management, and so on. The problem here that I see, that I've been working in network management for DSL equipment and also push-to-talk. And the problem was there that scaling was pretty hard. And we are talking about hundreds of thousands of subscribers. And what's coming to IoT is probably millions and then billions of devices. And it becomes a huge question how to provision them and how to manage them. We have heard presentations yesterday about how to balance this. So put some intelligence to the edge and have clever and more efficient protocols and have a proper provisioning on the cloud side. And this is all basically application dependent. And we are going to talk today about some deployment scenarios, a few words about the Google Physical Web, then in general OIC provisioning. I will say OIC because the standard's name is OIC still, and all the strings in the protocols, they are still OIC. And basically, the main points of the presentation are after this, it's in end-to-end provisioning, when I will show how I imagine to work with sensors provisioned through a service end-to-end. And then, basically, in parallel, I will show that how NFC could be used in this process and introduce in the end Web NFC, a few code examples. So the main use case here is that on the left-hand side, we have different classes of sensors that are connected on the right-hand side to applications. Now, the thing is that applications can have access to the same types of sensors. For instance, the first on the left, the smoke, fire, air pollution, and carbon monoxide sensors are needed by the ventilation system, the heating system, and emergency. If there is, for instance, a fire, the ventilation system must close down. It means that at least two entities have to share the actuator on the ventilation system. And this presentation is mostly about how to enable making these connections efficiently. We heard in yesterday's presentation that basically all is driven by data. And the questions today are that who owns the data and who can access the data. And these two questions govern basically the OIC security specification. And I will present them shortly. Before that, I'd like to say a few words about an alternative method to handle IoT, and that's the Google Physical Web. It consists of Bluetooth low energy beacons that are emitting Eddystone messages, Eddystone URI messages that are compressed, and they basically contain Bluetooth low energy service UUID and the URL. And as you walk in a place, you get the advertisement packets, your phone gets the advertisement packets, then it shows you a list of data transmitted, and you act on them by tapping what is interesting. So the data model is basically defined by Bluetooth low energy. We have their services and characteristics. The service UUIDs are the ones that are being broadcasted. And when you get a service, it has the characteristics list. And they are like properties. And they are standardized. For instance, they are like heart rate limits and so on. I have included links to the physical web if you want to check more. And my colleague, Kenneth Christiansen, has written an article about how easy it is to set up an IoT system on Edison just using the physical web notions. And the stack is really lean. I will show that in the next slide. But here I like to present that basically how complementary NFC and the physical web are. So basically, the physical web is running on Bluetooth low energy, but it can work also in Wi-Fi with MDNS discovery or UPnP or SSDP, whereas NFC is a short-range radio. It's like an order of magnitude difference. The data is compressed URI in the case of physical web, but NFC can carry URL, text, and internet media types on NFC tags that are like this, with small stickers, or NFC peers that are devices like this phone that supports NFC, or a USB dongle that supports NFC. In the physical web, the main difference here is that the physical web interactions are initiated by the device that broadcasts, the URI beacon. Whereas with NFC, the user goes somewhere and consciously does a push, a tap. So it reads something or writes something. And also there is a difference that how many devices see. For instance, the beacons are seen by everyone in range who has enabled the Bluetooth low energy scanning in their devices or applications, whereas the NFC is seen practically by one device. Okay, the range is like max 10 centimeters, but in the protocols, it's built-in collision detection. So basically, only one tag is going to be read. So in my opinion, they complement each other pretty well, because with Web NFC, you can broadcast a lot of stuff, and then you can go and act on them with NFC. For instance, you have a shopping mall, you walk around the hall, and you get advertisements, and then you go into the shop that interests you. You can get navigation there. You have NFC stickers on products. You can tap on them with your phone. You get information about them. If you want to buy them, just drag it in a basket and go to the point of sales terminal and just tap and pay. It can be really simple. So they complement each other pretty well, and you have the physical web where you walk around and do things. So how the basic operations are done in the physical web. We have we have the server and the client. The server is called peripheral. The client is called central. The peripheral is implemented by, in this example, by a Node.js module called Bleno, and the server side is called Noble. It comes from BLE and Node combined. And then you have a UUID on services, and on each service you have characteristics. So the client can basically go, the client is, for instance, a mobile phone. It can read and write and notify beacons. It can read the state. It can subscribe to state. So basically, it does the same that the OIC protocols do. Only thing that's kind of missing is the creation. And the point here is that you can do with different techniques. Actually, it's not specified how you should do it. I've seen there are manufacturers who have a provisioning interface which is proprietary or local, like with USB or Web USB or Web NFC. I have included links here to the specifications of Web Bluetooth and Web NFC and Web USB, since this client can also be a web page that uses Web Bluetooth. And then you can do the same things. You can basically read, write, subscribe to notifications. So I'm going to summarize a few topologies that can be used. In all these examples, my use case is that, for instance, I'm a startup that does IoT solutions. And what do I need to do in order to provision what I want to get the services running? So the simplest is that I buy a couple of sensors, and I want to configure them using my mobile phone or a laptop that I have at home or a PC. And here the sensor data is private, and I store it in a local device, and all is mine. The next one is a hybrid setup where I want to store the data in a cloud. That can be still a local cloud that's in my house, hosted in my house, or I can use some public cloud, or basically it can have federation between them, and I can solve the sharing use case via either by sharing directly the sensor data or by federation. But if I have multiple solutions with the sensors, there is the need that we separate those. And we specify that how they are going to interact. How can we provision the sensors to work with all those applications? The situation is more complicated when we add the gateway. The gateway is interfaces with the non-standard sensors that couldn't talk to the cloud or the mobile phone otherwise. And we have heard in other presentations there are many reasons that we can assume that there will be a gateway in IoT deployments. And this includes the case when we have only the sensors that communicate with each other, and basically the gateway is a role, so that one of the sensors become the master, and then it talks to the cloud and so on. There also can be a reality mix where I have my own private solution, but I also have a company deploying another solution, and I'm experimenting with a third one. And so I can use a mobile phone, a laptop at home, the gateway, and there can be an enterprise solution for security systems, but I want to control the ventilation myself, and so on. So how to provision all this? One of my colleagues said that it's very unlikely that one provisioning solution will fit all deployments. So we make simplifying assumptions. I've seen that in the OIC specs as well. That is basically application dependent. And my point today is that we should move provisioning complexity towards the cloud service. And that doesn't mean that normal operation happens mostly in the cloud, but basically the sensor should be fine working alone. But the provisioning could be done involving the cloud. So on the device side, we can implement simple mechanisms, and then we can have rules that come from the cloud, and we can follow those in the devices. I will have a slide about this later. Well, I will skip through this because everybody knows the OIC concept. So basically, I'm coming to provisioning. That's why I'm showing them. So we have the resource, which is the smallest addressable entity. We have the device that is basically the OIC stack. It contains the resources. Itself, it's modeled as a resource. We have the platform that contains devices. And it is also modeled as a resource. Now, what to provision? Basically, what we provision is identity. That is basically a device ID and a resource path for a given resource, and on the addressing space that maps to IP address and port. Also related to provisioning are discovery, creation of resources, and access control. And all these basically are handled by the OIC specifications. A few examples of what operations are possible with OIC. We know the discovery, the create, retrieve, update, delete, notify. That's known as a CRUDN set of operations. And we use RESTful APIs with the given identity and addressing that I've been summarizing the slide before. Just a point about discovery, that there are two kinds of discovery when we talk about provisioning. It's one kind that we discover non-provisioned devices. That's before the devices can operate. And then during operation, we have the normal OIC discovery. That's basically request on OIC REST resource, or in the Google physical web, is basically broadcasting the additional URIs and then on the other end, scanning them. So that's the normal operation. But during provisioning, we have a different discovery. And often, basically, there is a different network. On OIC standards, we have 3 steps, which is the first is onboarding, which is to establish the identity of the device and establish a trust anchor between a so-called ownership transfer method and the device to be provisioned. And the second step, we have the security provisioning, where we deploy the ACLs and credentials. And then comes configuration like location and time zone and so on. But in addition to the standardized ones, I'm going to talk about provisioning from which comes end to end. And for instance, we need to provision the cloud services with the resources we find, and we need to be able to tell the cloud what kind of resources we have. And currently, in our demos, that's done hard-coded. And I don't like hard-coded things. We try to make them parameterized. So I will show an idea how to do that. So the generic flow and the idea here with NFC would be that we attach, or the manufacturer attaches NFC stickers to the sensors it is selling, and that contains data about the sensors needed for provisioning. And then we have a home gateway. This is optional, but let's suppose we have it, and this needs to be provisioned with the sensors. And also assume we have a service, and the service here can be an application or a cloud service. And we need a device, and this is a role, which is a provisioning device. It can be the same device that actually runs the application that needs to provision these. So basically, I'm going to touch the device to the NFC stickers, read the data, tap the gateway, it gets configured, and also configures the service. So basically, we could say that the device is not needed. So in the simplest case, we just tap the sensor stickers to the gateway, and everything gets provisioned. Problem is that here we don't have visual feedback. Or if there are LEDs, like green LED, okay, it was fine. But I believe that the preponderant use case would be this one, that we have basically a provisioning device. And this would also act as an onboarding tool and a provisioning tool. So in OIC, we have the onboarding, provisioning, and configuration, as I also mentioned the slide before. And step one would be the onboarding. That contains the ownership transfer method, basically establishing identity, then setting up networking for the next stage, and also bootstrap the next stage, like telling who is the provisioning tool and how to find it, and credentials to access it. The ownership transfer method is awfully complex, and I'm not going to read this. I'm just going to tell that at some point, the onboarding tool device needs to discover the device is needing the ownership transfer. And then it queries on resources, and then has to establish a secure session. And there are 3 methods, or basically more, enumerated in the OIC security spec. And each of them is like 40 steps on the sequence diagram. It's pretty complex. The point here is that at least the just work method and the random pin method needs an out-of-band key exchange. And for that key exchange, NFC could be used. On the next step, we need to deploy credential types to the device that can be in symmetric, asymmetric, or certificate. And that can also be done by NFC. So the spec leaves this open. It's up to manufacturer whether they choose NFC here or not. But this is just to summarize where it could be used. So how would we use NFC tags? Since the sensors are pretty constrained devices, they probably won't have an NFC reader. It's pretty expensive still. It's probably price is going to be going down. But let's assume we only have tags. That's almost for free. So that tag would contain like what is the network preference of the device. It would contain a public key. And that can be used for the steps required by the OIC standard. So first we read the NFC tag to get the pre-shared key and the network preference for the later step. Then we establish the secure communication channel. Then we do the ownership transfer method, so we will have a device ID. And then we will update security resources. And then set up networking for the next stage and bootstrap the configuration server. These are the standard steps. Now, if we have an adapter, we can do more. So basically, when we tap the onboarding tool to the device, this device prepares NFC tag in its memory, and that prepares everything that's needed for provisioning. So the OIC steps here, these are the first 4 ones, they can be replaced by a single tap from the onboarding tool. So it counts as a secure communication channel, and it can establish device ID, it can update security resources, and it can update basically the configuration server URI, it can give credentials. And then we can proceed with the normal OIC procedure, basically setting up networking for the next stage and bootstrap the configuration stage. The second step is provisioning the security resources, like credentials, access control lists, or access management service. And here, the credential management can be in the cloud or remote. It can be remote or it can be local. So basically, in this step, the OIC will require setting up these. So after these are done, this can be done using the normal OIC methods or by NFC. How is it done by NFC? So here are the steps that are required by the OIC specifications. So basically, we create a secure connection, and the standard says that we need the owner pre-shared key to establish TLS, and then write the security resource, the credentials and ACLs. And then we can go on with normal configuration. So this step is basically the 5 and 6 belong to the configuration. But it can also be done during this step inside the device. So step 3 would be proper configuration, and that could be done by using the configuration source setup in the previous step. So we make a retrieve request, get configuration, and then we get the response with the configuration. Or it can be done, it can be provisioned directly to the device by the provisioning tool. So it's basically writing it. I will going to talk about the configuration mechanisms a bit. And this is work in progress. This is what's happening on the device side, for instance, in Ostro. And the idea is that a provisioning tool or somebody prepares configuration fragments that are needed to provision the device into the services. Now, the device will have configuration templates, basically rules. It knows how to set up the services it is using. These services have configuration files, but the input for those files can come from multiple sources. So what we need to do, basically in the first step, we deploy the configuration fragments, and that can be done using NFC, or as a matter of fact, also USB, or also by network, or you can use even Dropbox. After deployment, we have to parse and route. Basically, this means that we create the inputs needed for each configuration file that belongs to the services, and then we install them to the service and restart the service. And we also save the previous configurations, like we have a factory save, and we save each tree that we are doing, it can be saved. So this aligns pretty well what we heard yesterday about how to configure automatically devices. Basically, at some point, they need to contact a cloud service. They get configuration data and preferences from there. And then we have these general mechanisms how to deploy it. And the local knowledge is these configuration templates that comes from the manufacturer. Now, about how to configure things end-to-end. So we need to, when we have a service, a cloud service, and cloud services may include also the OIC services like credential management service and access management service. And they certainly have a data model which belongs to the application, and the resources will go there. And we have an application logic. Now, in end-to-end provisioning, we have 2 use cases. For instance, I'm a startup. I'm going to your house. I'm bringing the sensors needed with me. And those are new resources. And during the provisioning, the ownership will be mine as an installer. The other is that there are existing sensors in the house that the beneficiary wants to continue using and doesn't want to invest into new ones, so I need to share. I need to share the resources with other services. That will require that the services either allow each other to access these things, or we need a generic mechanism to do this. So how this would happen? This is a bit loaded slide, and down here I have 2 options. So how it is done today is that we write code in the service side to discover these sensors and resources, and then we programmatically select and provisions to our service the ones needed. And that's basically hard-coded. Or the other way would be to prepare these tags with the sensors, and then just tap the ones that I want to use. And then that information would go through the provisioning tool to the service, and then I have a parameterized setup for my service. So the first step would be to open a web page to the cloud service portal, authenticate, and open provisioning page. Then tap the provisioning device to the NFC tags on the sensors, and that will communicate that data to the service. Then on the service, we provision the cloud service, we update the resource model, and we can start observing the resource right away. So we can basically even skip the discovery. And in step 4, if we have a gateway, we can update the gateway configuration by tapping to it. And that would come basically to this scenario. And this, by the way, can be implemented both in the sensors and the gateway. Now, a few words about why do we need Web NFC here? The point of using Web NFC is that Web NFC allows us to access hardware, local hardware from a web page. So I take the provisioning tool, and I go to a web page. The browser downloads the web page, and I have the API that connects to NFC, and then I tap on it, then things will happen. It opens the application associated with it. And that allows the entire service code based on the cloud side. And we don't need to deploy applications to the device. Well, we may want to deploy applications, that's a manufacturer choice, but we don't need to, because I can go there with a general purpose browser that has Web NFC implementation, and I can do these things. So basically, there I would have on the cloud side the service provisioning code and the application logic. And that would look simpler when using Web NFC. Now, Web NFC is basically designed for browsers. It's not a low-level NFC API. And basically, it uses the NFC forums and the specification for data exchange. And we are basically implementing it on Chrome. But I have recently implemented on Node.js. And it's completely usable there, too. And Web NFC is basically developed in a W3C community group. And we get input from Mozilla and Google. So when there is at least chance for 2 implementations coming, then it may become a work group, and then can start on the standards track. A few words about Web NFC. So the main functionality is that we can control NFC adapters, like this one, from a web page. Because we are in a browser, we don't trust the web page. Therefore, basically there is if you read the specifications, then there are provisions for, it requires secure context to access the API, meaning the HTTPS. And the origin of the web page, when you write, it is written to the NFC tag. So we have a special format for Web NFC tags. The data on the NFC tags looks like there is a message, and the message contains multiple records, and each record can be like an internet media type. So we add a special record that stands for it has a Web NFC specific URN, and then the data there is the origin of the web page that tries to write. The main functionality is push or write NFC content to NFC tags or between 2 devices that support NFC, can communicate using NFC. And we can watch NFC content, for instance. We can say that I'm only interested on NFC tags that belong to my domain. And I can also specify path, that I am interested only in the NFC tags that are related to provisioning on my site. And why to use Web NFC? It's mainly because it's the same technology used in the cloud, the gateway, and the device. So because we have a Node.js implementation, it can be used in a gateway and the device. And in the cloud, we are using basically with web pages. And it's implemented in Chrome and Node.js. A code example of writing a configuration tag. So basically, the meat is here. We use the NFC object, which is the implementation of the API. I use the push method and give the message as a parameter. We could also pass options, but the defaults are pretty sensible. So I skip them here. And the message has been prepared as, it has a URL that can be filtered by the receiving end. And those are the watches. And that would be my portal IoT provisioning. And then it has the data, which in our case, I've been using JSON or text. And it has a media type and has the proper data. So I included there network preference, initializing configuration data like device ID, which is a UUID. And then it has links, like it has 2 resources. And the href stands for the resource path. So we have there the resource path for both. And we have the interfaces implemented and the resource type, which is light. And we have an on-for switch. And we also include a public key. So we use this in the way that I explained earlier. Now, what about watching? Well, I can set up a watch. It works like I need to set this up before anything is tapped. So it's basically preparing a listener, and it's waiting for somebody to tap. And I can filter based on URL and other things. But basically, I'm mostly interested in URL. That now I'm in provisioning mode. I don't want to be bothered by other tags. And I include a reader. And basically here, this code fragment just forwards it to the portal, the data that I get. And it integrates to the flow I presented earlier. We have Web NFC implementations. As I told, we have it on Chromium on Linux that is based on the NearD, the NFC daemon. That is an open source project, and it supports a couple of NFC adapters. And we have it on Chromium on Android based on the Android NFC implementation, which is one of the few that works. It's also, this is suitable for a provisioning device. So basically, when I'm testing, I'm using NFC-equipped tablet or phone, and that is used as the provisioning device. And the Node.js, basically, it's implemented also using NearD, that is part of Ostro. So how do I test these? So we have the sensors in our smart home demo. They are all implemented on Intel Edisons. And we prepare the NFC stickers. And by the way, the stickers don't need to be glued on the sensors. For instance, if you have sensors that are 6 meters high, you don't want to go there to tap. So you can keep them in a box and then label that this has been this sensor, and then later you can go and reconfigure if reconfiguration is needed. So again, here is the same sequence that I presented earlier. I opened the provisioning web page that's basically it's run on a laptop. And it has a REST interface, it has a database, it implements an application logic of the smart home, and it also has a provisioning web page. So I open that provisioning web page, and then I go and tap the tablet on each NFC tag associated to the sensors. And then the data is here, and it sends it to the server. Basically, the web page is going to process the data. And then I can do the service provisioning. I can take the resource data, for instance. There can be all the resource type, the resource path, the interfaces, and basically the whole resource state. And I can go and provision them to my data model. And then I tap the tablet to a gate to the laptop. And in this case, I use the laptop that I'm presenting here from and the USB NFC adapter. And then that updates basically the gateway configuration. And after this, the whole setup should work. So that's it. And if you have any questions, I can be reached by email or by this Zoltan Kis nick at every known social media. Thank you. If you have any questions. Yes?
So I noticed that the NFC wasn't used for passing the Wi-Fi credentials.
It can be. Sorry, a question was NFC wasn't used for passing the Wi-Fi credentials, but it can be used for that. And actually, when it comes to the, is it safe to pass that via NFC? When you, sorry, when you have a device, you prepare that information by the web page or anything, and it's pretty safe. You just tap, nobody can eavesdrop it. So it's pretty safe to pass that information with NFC. And that's why basically I said that we can replace full algorithms in the OIC spec by a simple tap. Because it's secure, nobody's going to eavesdrop it. And it can be encrypted if we want it. But so far, I think it should be fine. And by the way, when I write something on these NFC stickers, it's like I would write it on the wall. Everyone can read it. Okay, even though, for instance, if I tap my bus card to this tablet, then I'm basically getting an information page, and it can show me information, but I cannot write it. It has a specialized protocol, and I would have to know a file name and an application name. This is using basically NFC tag type 4. And that would be very hard to crack even by like brute force. It would be a lot of attempts needed for that. So I think it's pretty safe to pass Wi-Fi information. Any other questions? Okay. Thank you.